In this problem, we're going to look at an example RC circuit. This one's pretty simple. It just consists of one resistor, one capacitor. If we had multiple things, we'd have to use equivalent resistance, equivalent capacitance. But we've got a 20 kilo ohm resistor and a 0.3 microfarad capacitor hooked to a 12 volt battery. And part A says determine the time constant. Well, the time constant, tau, is just given by the resistance of the circuit times the capacitance of the circuit. In this case, that's 20 times 10 to the third times 0.3 times 10 to the negative sixth, which would be 6 times 10 to the negative third seconds, or if you'd prefer, that's 6 microseconds. So what that means is it takes 6 microseconds for this capacitor to reach 63% of its full charge. Question B says, what is the maximum charge of the capacitor? Well, when it's reached maximum charge, that occurs because no more charge can be forced onto these plates, and that's because the voltage across the capacitor will match the voltage of the battery. And so we can just say that Q equals CV, and that occurs when the voltage of the capacitor is the voltage of the source, which in this case I could use EMF, but I'm just going to use my capacitance, 0.3 microfarads, times 12 volts. Now I do have that micro in there, so I'm going to leave it, this 12 volts, and this is going to get me 3.6 microcoulombs. You could also report that as 3.6 times 10 to the negative sixth coulombs, but 3.6 microcoulombs is fine. And then question C, which I failed to put in here, says the time to reach 99% of Q max. Well, this equation, we have to remember that Q is equal to the maximum charge, Q naught, times 1 minus E to the negative T over RC. Now, we actually know RC, we found it, it's the 6 milliseconds. We also know Q naught, because Q naught is the maximum charge. This is 3.6 microcoulombs. What we're interested in finding is when Q is 0.99 Q naught. So I'm going to go ahead and rewrite this as 0.99, 99%. So 99% of Q naught is Q naught times 1 minus E to the negative T over RC. Now, we're actually solving for time. C says to find the time to reach 99%. Well, there's a Q naught on both sides, so I can go ahead and get rid of that. And so now I have 0.99 is equal to 1 minus E to the negative T over RC. If I add the E to the negative T over RC to each side and subtract 0.99, what I end up with is E to the negative T over RC is equal to 0.01. Now we have this problem of our unknown is actually up here in the power, which means we're going to take the natural log of this side, and if I take the natural log of one side, I have to take the natural log of the other side. The reason we do that is because if we take the natural log, that's log base E, that's the inverse of this power function, and so it just leaves me with the power. So now I have negative T over RC is equal to the natural log of 0.01. And so now I know RC is this 6 times 10 to the negative third seconds, so I can say that the time, negative T, is equal to the natural log of 0.01 times R times C, or times 0.006. And so if you take the natural log of 0.01, and the natural log is ln on your calculator, it's right below the log button, then you'll see that the natural log of 0.01 is negative 0.46, and when I multiply that by 0.006, I see that I get negative T is actually equal to negative 0.0276 seconds, or approximately 0.028 seconds, or you could say 28 milliseconds. So it takes about 28 milliseconds for this thing to reach 99% of its charge. About 4 times the time constant. So it doesn't take too long, and this essentially current will stop flowing. Now question D says the maximum current. Well, the maximum current occurs right when the switch is closed because there's no potential here, so there's no impedance, there's nothing preventing the flow of charge. This is essentially short circuit at the beginning because these plates act like charge reservoirs, and so all we have to do to get that is use Ohm's law, V equals IR, and so we'll use our 12 volts and we have I, and R is our 20,000, so 12 divided by 20,000 gets us a peak current of 0.006 amps. Make sure I did that right. 12 divided by 20,000, yeah, 0.0006 amps. So not a whole lot of current there.